Located on the far right side of the periodic table are the noble gases. These elements, 6 of which can be found in nature, are unlike any other elements. They don't play well with others, and they're pretty content to be by themselves. Nonetheless, they found a unique place in technical products, industrial applications, and even spaceflight. Learn more about the noble gases, aka the inert gases, on this episode of Everything Everywhere Daily. This episode is sponsored by Kachava. Hey everyone, I wanted to tell you about Kachava, my all-in-one daily super blend. If you're worried that you aren't getting all the nutrients you need or struggling to stay on top of your health, then listen up because Kachava has you covered. Kachava puts everything in your body in one glass, so you can have it all. All the superfoods, all the vitamins, all the omegas, all the adaptogens, all the greens, all the protein, all the benefits. For your gut, your skin, your hair, your brain, your muscles, your heart, everything. No more compromise, no more guilt, and no other nutrition shake does all of this. They traveled to the ends of the earth to source everything and then crushed it up. Kachava is a powder. You take 2 scoops of it and just add water and blend it up, and it tastes incredible. They have 5 delicious flavors: vanilla, coconut acai, chai, matcha, and my favorite, chocolate. I can drink 1 glass of Kachava a day, and it'll keep me full for hours. Trying to manage all the supplements and ingredients you should be taking can be overwhelming and expensive. But now, Kachava makes clean, organic, superfood nutrition accessible to everyone. So, you gotta try Kachava for yourself. Kachava is offering 10% off for a limited time. Go to kachava.com/everywhere, spelled Kachava, and get 10% off your first order. That's kachava.com/everywhere. In the past, I've done episodes on individual elements. I could probably do a full episode on helium, but once you get beyond that, it would be hard to do a full episode on the individual noble gases. So I figured I'd just lump them all together. But before I get into talking about the individual elements, I should probably briefly explain what makes inert gases inert. Each column on the periodic table is called a group, and what each group has in common is a valence number. A valence number describes the number of electrons that are in the outermost electron shell of an element. For example, the alkali metals such as sodium, potassium, and lithium all have 1 electron in their valence shell, and they are on the far left of the periodic table. The halide group includes fluorine, chlorine, and iodine. Every atom wants to have a complete outer valence shell. Alkali metals want to give up an electron, and halide elements want to take an electron to fill their shells. Molecules are created by elements sharing electrons, and how they combine will depend on their valence electrons. In the case of noble gases, they have a full set of electrons in their valence shell. They have no desire to give or take electrons. They're pretty good just as they are. This full valence shell is why inert gases are inert. It's very difficult for them to bind with anything, and there are almost never molecules or compounds found in nature with these elements. As a result, all of these gases are colorless, odorless, and monoatomic. There are 6 naturally occurring noble gases: helium, neon, argon, krypton, xenon, and radon. The first and lightest of the noble gases is helium. I've talked about helium before in several episodes. It's the second most abundant element in the universe after hydrogen. It has an atomic number of 2, which means that it's extremely light. Any helium which is released into the atmosphere will be permanently lost. If you let gas out of a helium balloon, that gas will eventually rise to the very top of the atmosphere and go into space, and it'll probably end up being caught in the solar wind. Helium was created in the very early universe, and it's also created in the inside of stars. However, almost all of the helium found on Earth today comes from radioactive decay, in particular, alpha decay. Now, if you remember back to my episode on radiation, alpha decay is when a radioactive element expels a helium nuclei out of its nucleus. Deep within the Earth, there is a large amount of radioactive decay. This decay is actually responsible for most of the heat inside the core and mantle of our planet. The helium which is created will gradually make its way up closer to the surface. Helium was actually discovered in 1868 in the Sun before it was found on the Earth. Most helium on Earth comes from drilling for oil and gas. As it rises up, pockets will get stuck in anticlines where oil and gas is often present. In 1903 in Kansas, when drilling for oil, drillers hit a gas pocket that, oddly, wouldn't burn. They had inadvertently found the first helium on the planet. Despite being one of the most common elements in the universe, helium is actually rather rare on Earth. You're probably familiar with helium and its uses in balloons and blimps. It's great for lifting, and it doesn't explode as hydrogen does. However, there are many other industrial applications for helium as well. It's used in certain welding applications, as well as in the creation of crystals. Liquid helium is also used to cool the powerful magnets in MRI machines. One potentially huge future use of helium would be for nuclear fusion. One isotope of helium in particular, helium-3, has great potential for fusion. The problem is, helium-3 is even rarer than regular helium-4, and it's usually created when a helium nucleus is hit by a cosmic ray. One possible location where there may be a large amount of helium-3 is on the moon. The development of fusion energy might just encourage more exploration of the lunar surface. There is currently a shortage of helium in the world. This has resulted in several physics laboratories canceling projects because they can't get enough helium. Today, as I am writing this episode, Harvard announced the cancellation of several experiments due to a lack of helium. Something to think about the next time you get a helium balloon. The next noble gas is another one you're probably somewhat familiar with, neon. Neon has an atomic number of 10, and I'm sure everyone is familiar with neon lights. Neon was discovered in 1898 after liquefying atmospheric air and figuring out what was left over after the major elements were taken out. Neon is the fifth most common component of atmospheric air, making up 0.0018% of air. Neon, being heavier than helium, doesn't escape to space when exposed to the atmosphere. The neon found on Earth is a combination of both primordial neon and neon from radioactive decay. 65% of the neon in the world comes from a single company, Iceblick. Iceblick operates in Ukraine and Russia, and as you can guess, this has resulted in a global shortage of neon since the start of the Russo-Ukrainian conflict. The price of neon jumped over 600% since the start of the war. They get neon by separating it from air. In fact, all of the noble gases, other than helium, are mostly acquired via a process known as cryogenic air separation. You liquefy air by cooling it down. The primary products are liquid oxygen and nitrogen, but you also get trace amounts of other gases that are in the atmosphere. The biggest use for neon, as you might guess, is for neon lights. When an electrical current is applied to neon, it will glow a bright orange-red. And if you see neon signs of other colors, that is usually due to coloring in the glass tube that contains it. Beyond that, there are some limited uses in lasers, computer chip production, and in vacuum tubes. In any application where you just want a gas that won't react with something, other gases are going to be a much cheaper alternative, such as the next noble gas, argon. Argon has an atomic number of 18, and it's actually the third most common element in air, making up almost 1% of the air that you are breathing right now. Argon is, on average, more abundant than water vapor and carbon dioxide in our atmosphere. The fact that it's so abundant means that it's much cheaper than neon or helium. If you need something very inert, argon is probably going to be the best choice due to cost. Carbon dioxide is often used as a fire suppressant, but in some high-tech applications, argon is used to put out fires because it's guaranteed not to react with anything else. Argon is a common gas used in welding, some aerosol cans, and as a preservative. The original United States Constitution and Declaration of Independence are encased in argon-filled containers. The next notable gas is krypton. Krypton has an atomic number of 36, and it's about 100 times rarer than argon. Krypton consists of about 1 part per million of the air in the atmosphere you breathe. You can get it from cryogenic air separation like all the other gases, but not very much, which is why it's so expensive. There aren't a lot of uses for krypton, because in most of the cases you could use it, you could use a cheaper argon instead. However, there are some very specific technical cases where krypton is more suitable, including as a coolant in high-end physics experiments. Small amounts are also used in some fluorescent lights, and sometimes as an insulating agent between panes of glass. Xenon is the fifth noble gas, with an atomic number of 54. It's 11.5 times rarer than krypton in our atmosphere. Xenon is the first noble gas that is above iron on the periodic table, which, if you remember back to my episode on how stars work, means that it's not produced in stars via normal stellar evolution. It's produced like heavier elements in a supernova and is a byproduct of radioactive decay. Xenon created by radioactive decay is actually a really big problem in nuclear reactors. The isotope xenon-135, which only has a half-life of 9.2 hours, is what is known as a neutron poison. In fact, it is the biggest neutron poison in existence. Neutron poisons can really impede nuclear reactors. Xenon poisoning actually contributed to the Chernobyl nuclear disaster, and it's something that nuclear engineers have to consider whenever designing a reactor. Xenon also plays a role in space travel. Some satellites use what is known as an ionic thruster. It simply uses electricity to expel gases that have been given an electrical charge. Xenon is a preferred fuel source for ionic thrusters because it's so heavy, which means that each atom expelled will provide more force. While xenon is a great fuel source, it's also really expensive, so many satellites have now shifted to iodine. The final and heaviest of the noble gases is radon. Radon is the only noble gas that is radioactive. It has an atomic number of 86 and was discovered by the Nobel Prize winner Marie Curie. It is a product of the natural decay of uranium and thorium via the element radium. There are very few applications for radon. What little radon that is actually collected for industrial use is incredibly expensive. It's collected via uranium mining, and it can sell for thousands of dollars per milliliter. It has some very limited medical uses, but most scientists can use it as a natural radiation marker in soil or groundwater. The biggest issue with radon is that it's a serious health threat. Because it is naturally occurring, radioactive, and it's the heaviest gas, it can accumulate in places like basements and mines. Radon will settle in low-lying places because it's so heavy. As it is a radioactive alpha-emitting gas, it's the second largest cause of lung cancer after smoking. Thankfully, radon is actually easy to detect, and if there's a buildup of radon, it's easy to fix with proper ventilation. I should note that there is a seventh theoretical noble gas. It would be element 118 in the periodic table, and it has been given the name oganesson. It doesn't exist in nature, and it's only existed in a laboratory for a few fractions of a second. It was named after Yuri Oganesson, who helped discover many of the heavy elements created in laboratories. The noble gases are very different than any other group of elements. They don't react with anything, and they have very limited uses. Yet, you've unknowingly been breathing them your entire life without even knowing it. Unless, of course, you sucked helium out of a balloon, in which case, you definitely knew it. Everything Everywhere Daily is an Airwave Media podcast. The executive producer is Darcy Adams. The associate producers are Thor Thomsen and Peter Bennett. Today's review comes from Sick Dagger over at Apple Podcasts in the United States. They write, I listen to this podcast every night. I love listening to this podcast. I've listened to every episode and usually set a playlist each night before I go to bed. My one complaint is that the intro music is a little loud and makes me jump sometimes between episodes. Otherwise, I spend most bedtimes listening to this podcast. Thanks, Kick Dagger. And I'm not sure if that was supposed to be Click Dagger, but I am honored to be part of your evening routine. I actually run every show through a program called Levelator, which levels out the loud and soft parts of the podcast. So technically, the music shouldn't be any louder than any other part of the show. So it's probably just a function of it coming along all of a sudden after a break in speaking. Remember, if you leave a review or send me a boostagram, you too can have it read on the show.